Okay, I can see quite a lot agenda today. So, today is October 28th, 2025. So let's get started from the first. So I'm going to walk through the progress of the current release. So
Did we lose Hankai?
Yeah, seems so.
Okay, I think he just came back.
oh, I was just lost, right? Hello.
Yeah, we can hear you now.
Okay. So we have planned quite a lot of features and programs in this release. So firstly, the multiple components workload scheduling. For so far, I think this is went well, and after the quota reserve quota and this my PR get merged, so we actually have a MVP version. So we might can release this feature in the next beta release, which will be cut at the end of this month. So I'm currently reviewing this PR. So okay,
Hankai,
since
are you sharing your screen?
sorry I didn't. Oh, my bad.
Okay, yeah, I can see anything.
It started as. Can you see now?
Yes, now I can see. Thank you.
Yeah. Sorry. So actually, I'm thinking after the MVP version, what we should do, and so today I just added another part of the feature. I think we should consider about how to make the test, including maybe introduce some in the test for the feature. So, and also during the review, I also think we might need to revisit the gRPC structure, as I noticed the current structure not that convenient, and I left some comments on the PR. So, Mihash and Weicheng, do you have any comments or ideas or something?
No, I think the part 3 sounds reasonable. I'm tempted to release this feature on dev for our users to test out, and then let's see if there are any sort of bugs that arise during the scheduling phase. We can let it cook for a little bit, and then if there aren't any issues, I can probably promote the feature to our higher environments as well.
Yeah.
So yeah, just waiting on the resource quota estimator, which I have to review that. Haven't taken a look at it just yet.
Okay.
Yeah, I will address the comments today, and I think it makes sense that because like all the component we assume like all the components share the same namespace. So I agree that probably should revisit the like the
Okay.
structure.
Oh, okay. Speaking of the namespace thing, I was told that the Flink deployment allows the two components can located in different namespace. Isn't that right, Mihash?
That I'm unsure about, unless that's a new feature that just got released. None of our users deploy their components in different namespaces, though.
Yeah.
If that's the case, then we'll probably need to reserve the current design, and then I will like modify the implementation, like checking the resource quota in different namespace.
Yeah, but I'm not sure about that because I don't believe it's a practical thing for allowing the different components in different namespace because in my opinion, the Flink deployment is a class is a namespace scoped resource, so it can. I don't know why people need to let's say put the task manager in namespace and another component name. Sorry, I forgot. And so
job manager.
yeah, job manager in another. I think no one would do that because because it's hard to manage the tenant resources usage. I think.
Yeah, and not only that, but the way that Flink operator is even able to provision its resources, like spin up task manager pods, is through a service account that's deployed on the namespace that the job manager ends up using as well. So I don't know how spreading those components across namespaces will work. Out of curiosity, who did you hear that from? Just so I can research it as well. I'm not familiar with the use case.
I just hear from Zhang Zhuang.
Oh,
So
okay.
Oh,
Fair enough.
so
I'm not very sure. I just see the Blink deployment CRD, and not, uh, I need to see it again.
yeah.
Okay. I mean, it might be possible. I'm just not familiar with it. So yeah, I'll do some research and see what the use case is.
Okay. So, Zhang, maybe you can share a link, share the document you're looking for, or okay,
Yeah. Okay.
okay, okay. So, let's move to next. The next is about best practice. So, we noticed that most more and more users are using the static wait to deploy their applications in HA mode. So we also noticed that there's some unexpected behavior like this one. This we now already fixed, and also we might still have some gaps, something we need to enhance. So this is the feature. For now, we have fixed all the bugs we ever know. So next, I'm looking forward to the feedback from some of the users. They are requesting the feature. So let's wait and see. And next is the Karmada operator about the PDB thing. So this feature is planned in planned several months ago, but yeah, this feature has been postponed a long time. So I think we can finish this in this release. So Joe, let me know you still need this feature.
Yeah. Right now I have operators that work around this, but I think it is a useful feature. Someone else volunteered to do it.
Yeah.
So as we approach the deadline for this release, if he's not able to finish it in time, then I can push a PR for it. I actually already implemented this, but just didn't push the PR because he wanted to do it.
Yeah, sounds great. But I believe the guy can finish this task because I am actually talking to this guy.
Okay.
Yeah.
Okay, then cool. Yeah. He
Okay.
already had a PR up, but you requested that he break it down. So when
Yeah.
he pushes that PR, then I can also review.
Okay. Okay. Sounds good. So the next is about the I think that's the technical dash. So oh, that's not actually not. This is the same thing about yeah, the following tasks are the sum of code and the RFX programs. So I don't like to dive into all of them. So that's almost the progress. So basically, the progress went well so far, and okay.
One question before we move on to the next topic.
Mhm.
For workload affinity, I know the scope of that feature is going to be pretty large. I think it's under review. Originally, I think we were planning it for 1.16, but I think at this point we're going to move it to the next release. I'm curious if we do get some time, maybe let's go over the proposal one more time. I'm going to most likely start implementing it internally, since we need the feature. And so as long as like the general implementation steps are aligned, I think I can at least work on it internally, and then we can start to talk about it more with the community in the next release. But yeah, I think I'm just gonna start working on that now.
Okay, sure. I can understand. So, yeah. Speaking of that proposal, I don't have a further comments so far, but as I mentioned on the PR, I need to explore the implementation or the design from the Kubernetes and see if we need to change something. Yeah, but I hope I can have enough time for maybe next month, and before the next release, we can have make an agreement on the proposal, and if we have time, we can start the implementation in this release. That's totally fine, but I'm not sure how much we can reach in this release.
I don't think it'll get completed in 1.16. That's definitely
Mhm.
not what I'm proposing. But I think
Okay.
what I'm gonna do is actually start seriously thinking about the implementation details. So we work in 2-week sprints here. I'm thinking in the next sprint, I'm gonna start at least solidifying the API decisions, and then also fleshing out the specific implementation details. I based most of the high-level implementation off of Kubernetes anti-affinity. So a lot of those details are pretty similar. I think from what I can tell, at least, anti-affinity is going to be a lot simpler to support than affinity. So I think I'm going to start with anti-affinity.
Yeah, sure. Okay.
But okay, I'll make updates to the proposal as I go.
Okay, sounds good. By the way, I asked the Kevin to look at the proposal, but seems he hasn't left any comment on that PR. But I will ping him again. Okay.
Okay, sounds good. Thank you.
Okay. Joe, next item. I will turn the desktop to you. So
Okay, I can share my screen.
ahead.
Let's see. Can everyone see my screen?
Yeah.
It looks okay?
Yeah, looks good.
Okay. I can start with this one. And before going into this, I can provide a little bit more context. So at Bloomberg, we built multi-cluster platform on top of Karmada. And a lot of work I have been doing recently for that platform is around observability for managed Karmada control planes. And as part of that work, I've also built some dashboards for the Karmada control plane components, such as Karmada API server, Karmada scheduler, and Karmada controller manager, and wanted to contribute some of those dashboards back to the community. Now, when I did that, that was with the assumption that whoever will be using those dashboards has already set up a monitoring stack, which is already scraping Prometheus metrics from those Karmada control plane components. And the main reason for that is because there's more than one way to set up monitoring stack. One way is to actually run the Prometheus stack outside of the Kubernetes host cluster where you host the Karmada instance. There's reasons for that. Usually you want to have a monitoring stack for observability into some Kubernetes cluster. And if that cluster is having issues, then you want to make sure you have a stack that's running independently of that cluster. Another way to set things up is to actually run the Prometheus stack actually inside the Kubernetes cluster. And there's the Kubernetes stack for doing that. When I submitted those dashboards, you guys requested that I demo how they work. So I'm going to do that today. And for the setup I'll use, I'm actually going to use the Kubernetes stack Helm chart to actually install the entire Prometheus stack inside of the host cluster where we set up the Karmada instance. And also, for anyone who's interested in replicating this setup, I provide this playbook for how to set it up. Can everyone see my Golang IDE? Yeah? Okay. Yeah, so last night I set this up to run through the demo. So if I find the clusters, I have a few clusters. So this is the host cluster. On that host cluster, I have a Karmada instance running, and then it's joined to 3 member clusters, 2 in push mode and 1 in pull mode. And I will walk through the playbook for how I set things up. So I just run hack local of Karmada to set this up, to set up the Karmada instance. And then I have some aliases for convenience. It's just for the Karmada control plane and then the host sector. Let me go back. Then I install the Prometheus stack in the Karmada host cluster. And to do that, I use the Kubernetes stack Helm chart from the Prometheus community Helm repo. That installs Prometheus. So in the monitoring namespace. That installs a few components. So it installs the Prometheus operator responsible for spinning up a Prometheus instance. And that includes Alert Manager, Grafana, Prometheus, and the node exporter for the Kubernetes worker nodes. But for our use case, we only care about Grafana and Prometheus. Now, I created a few dashboards. One of them is for the Karmada API server, which is the standard Kubernetes API server. Scraping metrics from the Kube API server is a little bit more complicated because the metrics endpoint for Kube API server is a protected endpoint, which requires authentication and authorization for the metrics resource URL. So to make things work, I actually create a certificate, a client certificate for the Karmada API server that I will give to Prometheus so that it can actually script metrics from the Karmada API server. And to do that, I have this script that I created. It basically will just look at the Karmada kubeconfig file, extract the admin client cert, package that in a secret, and put it in the host cluster so that Prometheus can use it. But let's say at some point in the future, we have first-class support in the Karmada operator for the Prometheus Kubernetes stack, then the operator will create that certificate. Once that's done, then you have to actually tell Prometheus how to script the pods. There's a couple ways to do this. One way is you create a service monitor that references some service, and then Prometheus will get the endpoints from that service to actually script the pods that metric, that service front ends. Another way is to create a pod monitor. It looks something like this. So this is telling Prometheus that it should script metrics from the Karmada controller manager pods, and that those pods emit metrics on the metrics port and on the metrics path. This is for Karmada controller manager. This one is for Karmada API server, it's a little bit more complicated because we have this TLS config part. And the reason being is because the metrics input for kubeAPI server is protected. And here I'm basically passing in the X509 cert that Prometheus will need to authenticate to the API server to get the metrics. Let me go back to the playbook. And then once I set up scripting, then I just get the credentials for Grafana. Expose Grafana and Prometheus on the host network via port forwarding. And that's the setup. And again, I have this playbook, so anyone can just clone, use this branch to run this as well if they want to play around with it. So now I'll go to Grafana. Oh, there's one more thing. After setting everything up, I have these dashboards that I import into Grafana. So if I go here, I have this Karmada folder, and in this folder, I imported the dashboards. This one is for the Karmada. This one provides insights for the Karmada member clusters.
Mm.
Now, if I look at the control plane, we actually have 3 clusters registered, member 1, member 2, member 3. But if you notice, member 3 is registered in pool mode. And those metrics I'm using to build those dashboards actually come from the Karmada controller manager, which manages those 2 push-based member clusters. And for the member cluster registered in pool mode, there's Karmada agent running on that member cluster, which I'm not scraping, which is why we only see member 1 and member 2, and not member 3. And here, each member cluster is a kind cluster with 1 node, so that's why we only see 1 node. And this is also showing allocatable versus allocatable metrics for CPU, memory, and pods. There's also resource utilization for the member clusters, and also latency for Karmada controller manager to ping those member clusters. And I build those dashboards using the metrics from the Karmada controller manager. This was using the cluster ready state metric. And the other metrics are also from Karmada controller manager. This one, the cluster sync status duration seconds metric, histogram metric. So this is the first dashboard. And actually, I can kill one of the member clusters. So if I do kind, delete member cluster, member 1, then in a few seconds, I should see that member 1 is marked as not ready. The scripting interval is, I think, what I configured was 10 seconds, so it'll take some time for this to be marked as down. But in the meantime, I can show the other dashboards. This one is for Karmada controller manager. And to build this one, I'm basically using the controller runtime metrics emitted from the Karmada controller manager, as well as general Go runtime and process metrics. I can filter by controller if I want. So for instance, the cluster status controller. And then I'll only see metric from that controller. And then the other one is for the API server. These are the metrics coming from the Karmada API server. So I'm running Karmada, well, I'm running version 1.31. This is just from the build info. And there's one replica running. Now, when Prometheus is installed inside of the Kubernetes cluster, it will actually by default script metrics from the host API server. So if I get rid of this label, then I'll see two replicas. One is the Karmada API server, and then the other one is the host cluster API server. And this one is just using metrics from standard Kube API server metrics. So latency metrics, request distribution metrics, payload size metrics, metrics per admission, webhooks, and watches. Also etcd latency metrics. And then these also general go running time in process metrics. These are the three that I have more dashboards, but before contributing them, I actually have to modify them to remove internal things. So over time, I will contribute more. And if we look at Prometheus, the way it works is for each pod monitor you create, the Prometheus operator will actually reconfigure Prometheus to add a scripting job. So if I search for Karmada, this is the scripting job for the Karmada API server. And you can see that it's actually using the cert I give it to script the script metrics from the Karmada API server. There's also a job to script metrics from Karmada controller manager. So basically that's how it works. It will dynamically reconfigure from Prometheus based on the pod monitor or service monitors you create, and create a job for each component you want to script.
Yeah.
Yeah, and if anyone's interested, you can just use this branch that I have. Well, I submitted this PR. Just take this branch and run the stack. I think that's all I have for this.
Yeah.
Now, to make those dashboards work, when I contributed those, it's without this label matcher. But to make it work with the Prometheus, in Kubernetes Prometheus stack, I added those jobs. But the ones I contribute are more general and don't have this label matcher. I have this label matcher in all of the queries because of how the jobs are dynamically configured by the Prometheus operator. But the dashboards I contributed are a little bit more general because it does not assume that someone is using the in-cluster Prometheus stack, because that's just one way you can run Prometheus. Prometheus stack can very well be running outside of the cluster.
Yeah. Yeah, that looks great. So first question, do you I see you already sent some PR for this. So is there enough guide for people to try this on?
Yeah, that's a good question. Oh, actually, before we go into that, let's actually go look at the other dashboard and see if member code, you see, and now it's not ready, right? The one I killed, this is the member cluster I killed. It's no longer ready. Yeah. So yeah, that's a good question. I wanted to do this in two phases. Phase one, contribute the dashboard, and then phase two, obviously, provide some guidance on how people can set up a Prometheus stack to monitor those control plane components. I haven't given much thought into exactly what that guide will look like. And the main reason for that is because in that guide, I don't know if it would be a good idea to assume exactly how they will set up Prometheus. It's more than one way to do it. Like for this demo, I set Prometheus inside a host cluster, but Prometheus can actually be running outside of the cluster. And when that is done, then the way metric scripting works end to end will also differ. So I don't know how people do this today. It would be helpful to know exactly how people set up monitoring for Karmada, if they do that at all. I don't know how they do that, but if I have that info, then I can bias the guide based on what most people report, right? If most people actually use the in-cluster Prometheus stack, then we can bias the guide for that use case, since that's what most people use. But if we don't have that info, then I can make it general enough that it would apply for any type of Prometheus monitoring stack setup. And for what I'm thinking, the guide would go somewhere here, right? In the documentation, there's some, we have some documentation for instrumentation. So Karmada events and Karmada metrics. We can add another sidebar here and maybe call it observability or telemetry, and then put some guidance there on how people can monitor Karmada control.
Yeah, that's a good idea.
Yeah.
Actually, I have seen similar Grafana dashboard from some of the users when they showing the dashboard to me. So I think it would be great to have a official document to tell people how to do this. Yeah.
And also, if you think it's useful, then, so let me go back to the playbook. Right? So for this playbook, I set up the Karmada instance using the script we already have, right? Arc local Karmada setup, and then just basically install the Prometheus monitoring stack with Helm, and then created this other script that packages a certificate for Prometheus to script Karmada API server. And then the pad monitors. If people would find that useful, then I can contribute this part we already have. I can create a script that sets up the remaining part, so that when someone does look up Karmada, subsequently they can do like hack, set up Prometheus, and then that will set up the entire Prometheus stack in the host cluster, and also install the Grafana dashboards, so that in a local setup they can see how this works. All of this is running locally.
Okay, so my question is, what my question is about the purpose of doing all this in Karmada repo. Does this to demonstrate how to launch the Prometheus stack for development or for production?
No, this would be for development, just like
just
development. Just like Hack Lookup Karmada is used for development. But that I'm not entirely sure about. I think it's only worth doing if people would find that useful. Usually for things like this, it's helpful for people to see how it works, right? So maybe it might be helpful if we provide a script that someone can use in local development to set this up. And then once they see this, then they would be inspired to have a similar stack in production.
Yeah.
I don't know. You can let me know what you think after you think about it.
Yeah. For now, one more question. So, you just mentioned the dashboard can now support the cluster with the push mode. So what about the cluster with pull mode? So can
Yeah, that's a good question. So the metric scripting is set up for the controller manager. For push mode clusters, I think it is possible. But the setup would be a little bit more complicated. Because when you register the cluster in pool mode, then the same controllers running in Karmada Controller Manager now run in Karmada Agent, right? That's running in that host cluster. So for a host cluster setup, we can actually still get observability into the push into the pool mode clusters if we have Prometheus Federation setup. But that's a more complicated setup, Prometheus. So let me find a good example. Okay, there's no image here. Let me find a good image. Okay, can you see this?
Yeah.
So with one way that can work is by setting a Prometheus Federation.
Yeah.
So this is showing. Let's assume this is US East 1, and there we have the Prometheus instance that is scraping metrics from the Karmada host cluster, right? And that the one in US West 2, that instance is actually scraping metrics from the pool mode member cluster, right? Then what we would do is have another Prometheus server, the central Prometheus server, and set up federation so that metrics from the Karmada host cluster, where the control plane is hosted, and metrics from the pool mode member cluster are all federated into this central Prometheus server. So we will have all the metrics, right? And then the Grafana instance would use the data source of the central Prometheus instance, and the dashboard we built in that Grafana instance would have the metrics not just from the Karmada Controller Manager, but also from the Karmada agent running on the pool mode member cluster. And with all those metrics, you can build in aggregated dashboards where we would not only see the push mode member clusters, but also the pull mode ones. But that setup is a little bit more, it would be a little bit more complicated, but it is achievable.
Yeah, sure. Yeah, I think it's totally doable because I have seen the some of the user doing the similar thing.
Yeah.
So currently, actually, I'm eager to try it by myself. So, but I don't know how to do this right now. So, do you think we can get started from the documentation and make a guide for people how to launch the whole stack?
For the basic stack, yeah. Yeah, we can do that. But that guide, we did show them how to do it using the Prometheus stack running inside the cluster.
Yeah, that doesn't need to be too detailed. Just tell people what component you need, where the, let's say, where the Prometheus should be installed, and how it integrate with the Grafana and something like that.
Yeah, I can write a guide for that, yeah. And then put it somewhere here. Maybe we'll have a sidebar called telemetry observability and then add a guide there. This setup is actually the setup I have, this federation setup. Yeah. I'm actually submitting a talk to talk about this at KubeCon EU. I'm going to share the proposal with you soon.
Okay.
Yeah.
Good.
It's going to be for KubeCon EU Observability Day. So,
okay.
Observability Day.
When the deadline for the CFP?
It's this weekend.
This week, okay.
Yeah. So KubeCon Observability Day.
I think you can just
yeah, it's co-located event. I'm gonna submit a talk to talk about. I will talk about how we have our monitoring stack set up. It's pretty cool. Okay.
Yeah.
So any more questions about this? I have one more topic I want to go talk about. Any more questions? Okay, I can talk about the next one. So this one is for standardizing the
It seems you just skipped the one topic on the top, right?
Which one?
The second topic is about.
Oh, I can quickly go over this. Is that okay?
The topic support option to control conflict resolution.
Oh, okay. Yeah. I want to first talk about this one since we're already talking about Prometheus. This one is also about Prometheus, yeah, which is why I want to talk about it first. If I go back here, let's look at this. So right now, for the metrics about member clusters, some of them have this cluster name label, right?
Sergio, can you zoom in your window?
Okay, let me only share this window. Only share Google Chrome. Is that better?
Yeah, better?
Yeah. So right now we have some metrics from Karmada about member clusters. Some of them have this cluster name label, which has the cluster name, such as member 1 or member 2. But some others use the cluster label. There's two issues with that. The first issue is that ideally, all metrics that have a label referencing a member cluster, I think should use the same label for consistency. And then the other issue with label called cluster is that it causes conflicts for some Prometheus stacks. For instance, if I go and look at the config for this Prometheus server and I look at external labels, we can see that some external labels have been set. Now, it's very common to run Prometheus NHA, especially when you have federation set up, right? If you have this type of federation set up, you'll have metrics coming from this Prometheus instance, from this one and this one, and all of those metrics will be federated into the central Prometheus server. By the time they get to this server, it's usually useful to have a way to identify exactly where they originated from. So for all the ones coming here, there's no strict rule about what the label should be, but in HA setups, one of the commonly used labels is cluster. So by the time metrics get here from this instance, most commonly, all those metrics will have a cluster label that says to EU West 1. And likewise, all the metrics from this Prometheus instance will have a cluster label that's also set to cluster. Now, and the way that is set up is for each Prometheus instance, you will have an external label called cluster that is actually the identity of that Prometheus stack. And if you have an external label that has the same name as a label on a metric, by the time the metrics are federated into the central Prometheus server, whatever value is set here is what would take precedence. So if we assume that this label is cluster name, but if we assume it was cluster and that the value was member 1, and that we had an external label here called cluster, and its value set to EU West 1, by the time the metrics make it to this central Prometheus server, the value we will actually see is not member 1, but EU West 1, which causes issues because all the dashboards that rely on that label will just stop working. Yeah. Which is why I think we should standardize on the label we use to identify the member cluster by using something more specific like member cluster or something else. Right now, we have some inconsistencies. Some of the metrics use cluster name, which is fine, and some use cluster. And this causes issues in Prometheus HA setups because cluster is a commonly used external label.
Yeah, I see. Yeah, I totally agree with your proposal, and also the way we are going to adopt the changes and for backward compatibility. So I'm no No comments from me. So just one question: do you want to do it in this release?
When is the deadline for this release?
Sorry.
When is the deadline for this release?
The end of the next month.
Okay. There's no pressing need from my side to have this as part of this release, but I can start on the work soon. Yeah.
Okay.
Okay. Cool. So this one. This one is for automated namespace management. So namespaces in Karmada are special. For all other resources, you have to explicitly create a propagation policy for Karmada to know how to propagate that resource to member clusters. But namespaces are special because the namespace controller by default will sync Karmada namespaces to member clusters unless you explicitly ask it not to. And that works fine. The issue we run into is that at Bloomberg, we have this managed platform built on top of Karmada. And we have tenants who want to migrate over to our platform. When they are migrating, it's likely they want to use existing clusters and have those clusters joined to a Karmada instance. Now, when those clusters are joined to that instance, since they already existed, it's very likely that those clusters already have all the namespaces that they're also going to create in Karmada. Now, when they create those namespaces in Karmada, by default, the namespace controller will try to sync those namespaces. And when it attempts to do that, given that those namespaces already exist and are not currently managed by Karmada, then there's going to be a conflict, right? Karmada will not just adapt those namespaces by default, which is why I think it would be useful to have a similar mechanism like this one to instruct the Karmada namespace controller that it is okay to adapt a namespace if it already exists. The way I envision that working is similar to how this is done. Our tenants would add a label to the namespace. I made that up, but we can pick up a better name. But basically, the intention would be, hey, Karmada, it's okay to actually adapt this namespace if it already exists in the member cluster.
Yeah, I got it. So my first question is what do you do when you let a legacy cluster joins the Karmada?
Yeah.
And do you migrate the legacy applications running on that cluster as well?
If there's applications running?
Yeah, I mean, when you join the legacy cluster to Karmada, do you need to migrate the application to Karmada?
It depends. There's probably things already running in that member cluster. Whether or not they want those also managed by Karmada will be up to them.
Okay.
If they want that, then they'll create propagation policy to have, and in that propagation policy, they most likely will set up the conflict resolution to have override so that Karmada can adapt the application.
Yeah. So generally speaking, my opinion on the labels on the labels is we should be very restrained before introducing a new label, because the label is kind of the magic thing, you know. So for users, it is something backdoor. I know, I'm not sure. Something like a backdoor. They hard to use actually, and the feature is not that visible as the APIs.
Yeah.
So another concern for me is about the label is the label is kind of the one-time thing. So another approach I'm thinking about is, should we consider to enhance something for people to for Karmada to manage the legacy cluster more smoothly? Maybe that's why I asked the first question. So can we migrate the namespace during the time we join the legacy cluster to Karmada and do yeah.
I see. Yeah, what I'm proposing is just one way of doing it. If you think there's other ways to do it, then I'd love to hear what you were thinking.
I don't have a clear idea in my mind so far. So basically, I'm thinking, what can we do, or what should we do to help user to migrate the things from the legacy cluster? Yeah, maybe the namespace should be migrated, or introduce another another controller, something like it can automatically migrate the namespace. I'm not sure.
Okay, I see. Yeah, we can think more about it to see what makes most sense. Yeah. Okay. This. So this one is for adding admission to Karmada operator. So right now, all validation and defaulting is done inside the controller, right? So I wanted to add this feature so that we can have admission control as part of in the Karmada operator, so that defaulting and validation logic will run as part of a webhook, which is a best practice. We started talking about this, and last time we talked, yeah, you were wondering if we can introduce this as an option. I already created a PR for this and tested this. It works. So I think the last thing to figure out is if we actually want to make this optional. At first, I made it optional, but then remove that option so that those validation, the webhook would actually run by default. And the reason why I did that is because eventually I think this is a change that we're going to have to introduce anyway. So I think now might actually just be the right time to do it.
Mm-hmm. So you prefer to keep the legacy validation and the webhook at the same time, right?
No, the defaulting and validation logic will remain as is. With this change, instead of running in the controller after the resource is created, they will run in the webhook, in the admission webhook.
Mm-hmm.
The logic itself does not change. What changes is when it runs. Right now,
Yeah.
if I create a bad Karmada custom resource, it will get admitted to the API server. But then at runtime, Karmada operator will fail to reconcile it. And at that point, it most likely will be unclear to a user what happened, and they will have to do some digging to look at events and things to see if something went wrong. With admission control, if I create a bad Karmada CR,
Mm-hmm.
the admission webhook will prevent it from getting admitted in the first place.
Mm-hmm. So I mean, the currently the validation is happening. The validation is performed during the
Yes.
reconcile loop, right?
Mhm.
Uh, if we introduce the webhook, do we need to still keep that validation in reconcile?
No,
In
yeah. That's a great question. No, we will no longer need that logic in the reconciler. It will run as part of the admission webhook.
So all validation done by the webhook, right?
Yes.
So that would make the command operator the command operator will become a service, right? Because the kube AP server needs to talk to the command operator.
Yeah. So I added that's part of the Helm chart. So when you install the operator of the Helm chart, it will also install the service. Pretty simple. It will just create the service. The Helm chart will set that up.
So we still need to let the command operator accept a configuration for the certificate, right?
The certificate will be provisioned by cert manager.
Mm-hmm.
So with this change, a user would need cert manager running in the host cluster. But I don't think that is a big deal because cert manager in Auspice is the de facto standard for managing certs. And most people already have cert manager installed in cluster. But cert manager is what will be responsible for provisioning the certificate for the webhook.
Me too. I don't think the cert manager is a thing here. Only thing I'm not sure that if it if it was to do that change, because that would make the command operator the maintenance effort for the command operator would be more higher. I mean, for the users, because the user should maintain another webhook configuration, right?
So if you have a admission control, you do need the webhook configuration, but this is not something the user will have to worry about. They will just install the Helm chart, and as part of installation, the Helm chart will install the webhook config. They don't have to worry about it. They just install the Karmada operator exactly how they do it today. Just Helm install, and the Helm chart will set everything up. Yeah. The user won't have to manually create this.
Okay, I see.
Yeah. And also, I think that puts us on the path also to adapt cert manager for managing the cert in the Karmada operator. I see some users are actually asking about that in the Karmada Slack. They're starting to ask about cert manager introducing the operator.
Okay.
But that's something that will happen down the line, not right now.
Yeah. Is this feature is kind of a blocker for your use case?
Right now, it is not a hard blocker, but I think it is a best practice that eventually we have to do. And right now, it's kind of awkward how it works. Like if I create a bad CR with admission control, I will know right away because it won't even get admitted. But right now, it will still get reconciled, and then you have to go and kind of like figure out what happened to and why it was not reconciled. Yeah.
Okay.
But it's not a pressing need, right? It's not something that needs to be done like this week, right?
Okay, sure. I understand. So, I think I'm going to involve the the previous author of the Karmada operator. Let's see if he had some further comments.
Okay.
So we actually we have talked a lot about if we need to introduce the webhook in the first place, and I think we made an agreement that we want to keep the operator easy to use. We don't need to bring too much dependencies for the operator. So we use the reconcile to do the validation.
Yeah. Oh, I see. Yeah, I think you made a.
Yeah, I left a comment about.
Yeah. Okay. Yeah. At that time, yeah, I don't know if there was support for having the webhook running as part of the same binary. Today, it's actually, I don't know how that was back then, but today it's actually very straightforward.
Yeah, I see.
You just register just like you register a controller, and it runs as part of the same binary. Yeah.
Yeah. That's another thing I want to explore more is why we didn't notice that the control runtime support running the webhook inside the instance. I'm not sure if it is the recently feature or we totally missed this feature. So
Yeah,
I'm not.
maybe. So today, actually, to your point about maintainability and simplicity. So today, right, we have a separate component, Karmada webhook, right? With this feature, the webhook can actually run as part of the Karmada controller manager, right? That's possible.
Yeah.
It's something we would have to explore, but it is possible. Instead of having this extra component, the webhook can be registered as part of the same controller manager binary.
Yeah.
And
I
then
see.
it would be just one less component that we actually have to maintain.
Yeah. Okay, sound good. The less components, the better.
Yeah.
Actually, we have too much components now.
Yeah, there's a lot of components there.
Yeah.
Okay. Yeah, just let me know what you think about this after you talk with him.
Okay. I will leave some comments and involve some guys.
Okay.
To comment. So.
Okay. Cool. And I think, yeah, I think that's it. This is all I had. Thank you.
Okay, thank you, Joe. So I'm going to share my screen. Okay, the next, the last topic is I want to make a quick think of the plan of KubeCon Europe next year, and this time we have we have a opportunity for submit the maintainer track and also a project lightning talk and a kiosk and also the maintainer summit. So what do you think for are you want to be part of the no matter the maintainer track or project landing talk and kiosk? Let me know.
If you need help with the lightning talk, I can do it. I'm gonna be going to KubeCon.
So product lightning talk, right?
Yeah, if you need help with that, I can do it. I'll be going to KubeCon next year.
I'm curious, for the maintainer track, how does it work? Do we all present together for the project as a whole, or because I'm not familiar with the actual maintainer track?
Maintainer track. Okay. The maintainer track is sorry. Who is
Oh, sorry.
speaking? Okay. Okay. The maintainer track is runs is almost the same with the normal track, including the time. But the maintainer track can have at most 5 speakers. So the normal track can only have 2 speakers, I guess. So that's not so the maintainer track are all located in the middle of the other normal tracks. So
Okay. If we're planning on doing just an overview of where the project is, I would be happy to talk about like federated resource quota and also workload anti-affinity. I think those would be applicable.
okay, sure. So basically, my idea about the maintainer track is dive into three parts. And first, maybe the basic and a quick introduction of Karmada for the audience that are not that familiar with Karmada, and then share some updates last year. And then next is if we have some end user at that meeting, we can let them to show the use case. So how does that sound?
Yeah, that makes sense to me. So what we could do is I could show some of the real world use cases for the new features we worked on.
Okay. Okay. 你好，看。So we have 5 speakers. So we at the last community meeting, one in the user from China, he shows interest to the meeting to the track. So I'm not sure. I need to confirm with him because he need to get support from his boss. One more placeholder.
The maintainer track will have five speakers.
Yeah.
5 speakers.
Yeah, I'm sure.
Okay.
Yeah.
Okay. I see.
Yeah. It's amazing, right?
Yeah. I thought it could only be like 1 or 2. I didn't know it could be
yeah.
5.
It's for the normal sessions, it's 2.
Yeah.
For maintainers, it's 5 though.
Okay.
Yeah, I can also help on the maintainer track or kiosk if there is any place.
Okay, sure.
Okay.
Wei Sheng. Yeah, sure. Here, maximum 5 speakers.
Okay. So
Okay.
I think
Shown here, and also yeah, for the kiosk we do need more people to help because usually we are going to have a 3 morning and yeah.
Okay. So for maintainer track, I think one way it could be done is like one person does a basic and quick intro, then a use case, which Mihash can do, and then project updates. So basic and quick intro, I guess, would be similar to like lightning track. So I can do that one. And then I guess Mihash can do real world use case and then Wei Chen project updates.
Do you mean you are also want to be part of the maintainer track, right?
Yeah, I can do the basic and quick intro part to just let people know what Karmada is.
Okay. Sound good. Okay, sure. So for the next, I think maybe I can make a template for the maintainer track. So every year we can just make an update on that slide. So let me try, and I will send the link once I made it. Okay.
Yeah, thank you. Oh, just some. I want to know more about like kiosk. You will do we need to submit like CFP for that?
No.
We
No.
just be there and then like talking with like someone who is interested in this project, right?
Yeah. We don't need to
Okay.
send the COP, but just a form. I will to submit a form.
Okay. Kiosk is basically the booth, right? Project
Yeah,
booth.
exactly.
Okay. Kiosk is more fancy name. Okay.
I'm happy to
Yeah.
help out with the kiosk as well. I don't know,
Okay, sure.
but yeah, if you need people there, more than happy to help.
Yeah, that's pretty interesting. You might need you might meet a lot of people. They may talking to you interesting use case there.
Okay.
Yeah,
So
sounds good.
it's basically booth. Okay. So I can help out with kiosk as well. 'Cause the way it will work is we will just alternate,
Joe wants
right?
to do everything.
Yeah.
Jill is a Superman. Okay, that's all. For the maintenance summit, an update is all the Karmada members can join the maintenance summit without any request or sponsor. So that's kind of the benefit. You can see here. Oh, maintenance summit. Okay. Oh, sorry. Here. Okay, see who can attend the maintenance summit. Yeah, for incubating product, org members can attend the maintenance summit. So I think all of you can attend the maintenance summit. So okay, that's all. So since it's running late here. No more people join the meeting. So maybe let's keep in touch on GitHub and see you next time.
Yeah.
So see you. Nice seeing you, Honkai. Later.
Thank you.
See you.
Bye.
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 Bye.